AC circuit. So as far as techniques to actually solve problems, I don't think that their AC circuits are that much different from DC circuits really, because we still apply KVL, KCL, and everything else. The only difference here is that we have sinusoidal sources, either current source or a voltage source, because it's alternating current, and the current is produced from the application of a sinusoidal voltage pretty much. And also we're dealing sometimes with complex numbers and trig expressions. So that's the only difference. Otherwise, we still use the same techniques. So in this particular problem here, problem 1, compute the power delivered to the 25 ohm resistor. So the power over here. So what's power? Again, power is I squared R and so I know what R is going to be. It's going to be 25 ohms, and so all I need is to find I. Okay, so I'm going to go ahead and assign my signs, and here's plus minus here. I can put plus minus here, plus minus, and plus minus, just to keep it easy. Okay, and so I'm going to assume that there's a current here, I1, through that first loop, and then I2, second loop. For the signs, you can actually choose your own, and we're still going to end up with the same answers. So, but just make sure you are following the standards. Okay, so KVL, we can apply KVL here. So going from minus to plus, it's positive, so we have 10. Okay, going from plus to minus, it's minus J15, and then that first loop is I1. From plus to minus, that's minus 15, but we have two currents going in and out, so we have I1 and we have I2. For I1, it's from plus to minus, so that'll be minus I1, and I2, it's from minus to plus, so that'll be plus I2, and that is equal to 0. For the second loop, we have from minus to plus, and so that's 15, so that's positive 15. Well, yeah, actually 15, but then we have two currents going in 15, so again it's gonna be minus I2 is from minus to plus, and I1 is plus to minus, so same thing here anyway. So that's minus I1 plus I2. Okay, so plus to minus, so that's minus J30. Well, actually minus J30, so that's plus J30. And we have I2. And here we have plus minus, so that's minus 25 I2 equals 0. So let's clean that up. So we have on top, we have two I1s. So we have 10 is equal to it'll be J15 and 15 I1, so J15 here, and wait, yes, minus 15. I think, right? Because yeah, you're bringing this to the other side, so it'll be J15, which will be positive, and then you have minus 15 I1, Oh, actually both I1 is to both multiply. So minus 15 I1 like that. Okay, and we have plus 15 I2. Right, and you guys can peer check me too if I don't get the signs right. Okay, so at the bottom I have minus, so I have 0, I guess. Minus 15 I1. Okay, and I have 15 I2, 15 minus 25, that's 10 I2. Plus J 30. I'm looking at the answer because I'm using a book here. I'm not sure if I can say the book the name of the book for YouTube, but I don't have the same answer, which is kind of weird. So it would be helpful if you guys can let me know if I'm doing it right or wrong, because it's definitely not the same answer at all, and I'm following the right rules here for KVL, but it doesn't come out to be the same. But anyway, you can peer check me and put those in the comment section, please. Okay, so I have that 10 plus J 30. Maybe I'm doing something wrong, but I follow all the sign rules. Let's see here, plus yeah. Minus 15 I1 plus, where was I? Okay, so that's weird. Okay, but anyway, I'm gonna continue with this. You get the point anyway. We just apply KVL and find I2. Okay, so so let me write this in standard writing. So I have J15 minus 15 I1 plus 15 I2. That's equal to 10, and I have the bottom minus 15 I1 plus, I just like to have the those numbers to the right for some reason. So I have 10 plus J30 I2 equals 0. So all we need to do is just find I1 and I2, and this is going to take a while, I guess, unless we put it in the calculator. But I don't want to continue with this. I'm going to check the book again, but in the meantime, if you guys are watching this, you could also solve it on your own, apply KVL, and let me know if you have the same. Let me show you what the book has. The book has, this is what the book has. Let me put that in red. So the book has this from the book. So I'm not sure if it's me or the book itself, but the book has 15 plus J15 I1 minus 15 I2 equals 10. And then they have minus 15 I1 plus 40 minus J30 I2 equals 0. So obviously there's a a little bit of difference here, minus signs and plus signs here. The 15 on top, let's see, if I multiplied here by minus, I would have gotten here. So it's not really a minus sign issue, because if I multiply here by minus, I would have had a plus 15 here, but then a minus here, which would have made this minus and but I'm not gonna try to find here. I don't want to copy whatever the book has. I just want to follow the rules and get the answer so I know I understand. So that's the reason why I'm a little stuck here, but if you guys can help out, that would be really good, because I'm not sure if I'm wrong or is the book wrong. Okay, so let's move on from the problem. I'll get back to this one maybe next video or something to clarify. Okay, so next problem. Find the value of XC so that I is in phase with VS. So how do we get the current to be in phase with the voltage? So basically, the total impedance seen by the generator must have a zero impedance. I mean a zero, not impedance, but it's zero imaginary part. Okay, so here we have the total impedance seen by the generator would be these two in parallel plus in series with this, but we wouldn't add the the imaginary part. Okay, we wouldn't add that. So these two together in parallel, we have J20 XC over J20 over J20 minus JXC. So that's these two in parallel. Remember, I'm trying to find the total impedance seen by the generator so that I is in phase with VS, and for that to happen, the generator must have a the total impedance seen by the generator must have a must have a zero impedance, zero imaginary part. So this is these two. Okay, so let me simplify this first. Okay, so that would be 20, wait, because J squared is minus 1, so J squared is minus 1 and the 1, so it's positive here, so that's 20 XC. And at the bottom, we can pull out the J and have 20 minus XC here. Okay, so the total impedance seen would be J60 plus, because it's going to be in series with whatever I got here, so plus 20 XC over, well, no, actually, you know what, it is zero imaginary part, meaning I'm adding the I'm gonna add the imaginary part and equals that to 0, right? Yeah, that's what it is. So I would have J here, I would have minus here, minus J 20 XC over 20 minus xc. Now this is equal to 0, right, yeah. So that's equal to 0. Okay, and so so we have to solve for xc. Okay, so xc would be would it be 15? Let's see here. Okay, so xc is equal to 15. Okay, so to kind of put everything into perspective, the question here is find the value of xc so that the current, is in phase with Vs. And to make I in phase with Vs, the total impedance seen by the generator must have a 0 imaginary part, the total. Okay, so that's why we added the imaginary part, put it equal to 0. We didn't add we added the imaginary part equals that to 0 and finding xc basically, and we find that to be 15. Okay, moving on. New problem: calculate resonant frequency and quality factor. So going to the book, on page the FE book on page 196, resonance. So what's resonance frequency is for this problem is page 196 on the FE book. We have omega 0 is equal to 1 over, let me write, 1 over square root of LC, and we know everything. So L is the inductors, yeah, 3 millihenries. So square root of 3 times 10 to the power of minus 3 times the capacitance is 2 to the power minus 6. So omega 0 is equal to let's see. Okay, so I have 1.29 times 10 to the power 4, and this is in rad per second, radian per second. Calculate quality factor. Still on the same page 196. Quality factor is Q, so Q is equal to R over omega 0 times L. Is that right? It's the opposite, actually. So Q is equal to omega 0 L over R. So omega 0 it's already been calculated as 129 times 10 4 times L is 3 over 10k, 10,000. Okay, this is for this formula right here. There's two. That's why I was a little hesitant, because there are two formulas for quality factors, one for series and one for parallel. And over here we're dealing with a parallel resonance, so it's a different formula. Same thing. I mean, it's the first one that I wrote. Yeah, that's right. So this is R over omega 0 L. Because I was looking at it and I'm like, okay, I have two resonance, but I wasn't reading series, I wasn't reading parallel. Now I got it. Okay, so this is parallel, of course. So that's R. R is 10k over, we already know what that is, 129 4 times L 3. So whatever this is divided by 129 times 258.4. Q. What's the there's no unit for Q? Oh yeah, it's a factor. Duh. Okay. Yeah, sorry. It's a factor, so factors don't have units. Quality factor. I guess I haven't dealt with a lot of questions with quality factors. I don't think I even learned that in class. I know of resonant frequencies and stuff, but quality factor, not really. But anyway, that's a formula, and I got that straight from the handbook. Okay, I have a problem here. 3.x. I just threw that in because I thought it was interesting. Let's go there. Okay. Find effective value of voltage for waveform. So still in the handbook on page 195, we have the effective value is given as this effective value. Of voltage, I guess. Okay, so let me write what I see in the handbook. XEF, X effective, I guess, is equal to X RMS. Maybe I should do this problem in the next video because I'm already at 25 minutes. Okay, so I'll solve this problem in the next video. Thanks.